it's really interesting. Astronomers are looking for rocks near Earth, and they move at a speed that is 1 part in 10,000 of the speed of light, okay? So, in fact, it gets to an extreme where there is a new observatory that will start operations in a year in Chile called the Rubin Observatory. The National Science Foundation invested almost $1 billion in it, and it will have a camera with 3.2 billion pixels looking at the southern sky and surveying the southern sky every 4 days. And when I asked scientists involved in this telescope, are we going to see interstellar objects? These are objects moving fast that are not bound by gravity relative to the sun. And they told me that, no, for now, the software is just looking for the standard asteroids or comets. And this is after we already know that there is a population of interstellar objects, and we can talk about them. And so together with my postdocs, we're actually developing the software that will identify objects moving. But for example, the Rubin Observatory won't be able to tell if there is an object moving close to the speed of light, because there would be only one frame of that object moves too fast across the sky. And so there could be, a lot of objects passing near. The only ones we can actually detect with astronomical observatories are those that are bigger than a football field.
Yeah.
We can see them through the reflection of sunlight within the orbit of the Earth around the sun. They have to be bigger than a football field. Even Starship, the biggest, rocket that Elon Musk built, even that is not as big as a football field. So our biggest rocket is barely, not even detectable with our most sophisticated telescopes within the orbit of the Earth around the sun. I'm not talking about farther away. There could be a lot of small objects the size of a person, passing through space without us noticing. The only time we would notice if they collide with Earth and burn up in the atmosphere as a meteor. And by the way, just a few weeks ago, there was an explosion of a meteor over Berlin in Germany, roughly 1 meter in size. And then it broke up and the fragments were scattered. And one of my team members went there. He's in Berlin, and he reported back that the meteor was moving along a line. You could see it from the fireball that was created as a result of its friction on air. And then the fragments were found perpendicular to the path. And so I said, wow, that is really interesting. They were found on a line in farms that were under that path, perpendicular to the original fireball of the meteor. And so in the morning, after he told me that, usually I wake up at 4 a.m. because I jog just at sunrise every day. And today, for example, I woke up at 2 a.m. because I had to write a paper, and we can talk about it.
Yeah.
But so I woke up at 4 a.m. and I did a simple calculation which showed me that even fragments that are, as big as 5 centimeters, something like that, they would be slowed down very quickly on the surrounding air. And so they would be carried by the wind. And the wind was actually going perpendicular to the meteor path. So basically what you see is the winds scattering the debris from this meteor. And I calculated also how far they would go and what was the wind speed and so forth. And the amazing thing is physics works. Everything is falling into place. He was just telling me the facts, and I was able to explain all of them. So what happens is when a fragment is going through air, it's just like droplets of rain. You realize the droplets of rain eventually reach a terminal speed, a fixed speed, because the friction that they have on air is balanced by gravity. Okay, so then they reach a constant speed that reflects the friction being a strongest gravity, so they move at a constant speed through air. And the same is true for these fragments. But the bigger the fragment is, the more gravity acts on it, and therefore the heavy pieces fell closer to the meteor path, and then the lighter pieces fell farther away. And I calculated it works perfectly fine with all the data there is. And the amazing thing about this meteor near Berlin, on January 21st, 2024, this year, is that there were these big fragments. Why is that important? Because a decade ago, the US government satellites discovered the first interstellar meteor. Nobody recognized it. They just collected data on the speed of the object. And 5 years after the report from 2014, January 8th, 2014, I realized that NASA cataloged meteors, and I asked my student, Amir Siraj, to look into the catalog and find the fastest meteors. And we found this one from 2014, and we noticed that its speed is faster than 95% of all the stars in the vicinity of the sun. So it came from outside the solar system. And moreover, it was made of materials that were tougher than even iron meteorites because it disintegrated in the lower atmosphere and at a much larger stress than all other meteors, 272 of them, in the NASA catalog. So to me, it sounded fascinating because maybe it's a Voyager-like meteor. Imagine Voyager leaving the solar system in 10,000 years and eventually colliding with a planet like the Earth. It would appear as a meteor of unusual material strength and speed. And of course, astronomers would say it's a rock of a type that we've never seen before, but I would like to know whether it's a rock or something else. And so I led an expedition to the Pacific Ocean to examine the small droplets that melted off the object when it was exposed to the fireball, the immense heat that was generated by its friction on air. And amazingly, we spent 2 weeks there. The expedition cost $1.5 million, and we built a sled with magnets and carried it on the ocean floor across a region that is 7 miles in size, and the ocean is a mile deep. And we managed to retrieve 850 spherules, molten droplets, less than a millimeter in size, the size of a grain of sand. And the reason I had to wake up at 2 a.m. this morning is because we are finishing a very extensive paper on the results from the analysis of those materials. We used 2 laboratories, one by my colleague, Professor Stein Jacobson at Harvard. He's a world-renowned geochemist. And the second laboratory in Berlin, Germany, led by Dr. Roald Tagel at the Bruker Corporation. And what we found is very special type of materials near the meteor site. And by the way, that site was localized by the Department of Defense, the satellites that looked at it. And also the US Space Command confirmed the interstellar origin of this meteor in an official letter to NASA. After some of my colleagues raised doubt that the US government doesn't know what they're talking about, they measured the speed wrong. So they went back and confirmed this conclusion that it's interstellar. And now we found those materials that have a composition of elements that is different from solar system materials, different from what you find on the crust of the Earth, the Moon, Mars, asteroids. It has some elements that are 1,000 times more abundant than the primordial, the initial composition of the solar system. Elements like uranium or beryllium or lanthanum. We call that composition Belau for beryllium, lanthanum, uranium. And we analyzed 12 spherules of this composition. We believe they are of order 10% of the spheral count that we had. So there could be about 80 of them in our materials, but we analyzed 12. And we now completed the analysis, and we are summarizing it in this paper that I was working on since 2 a.m. this morning. And it's very exciting because, science, the beauty of science is that it's based on evidence, not on opinions. because there were a bunch of scientists who had very strong opinions. You will not find anything. You shouldn't go to this expedition. So I went there. You will not find any materials. We found some materials. The government data was wrong. This material has nothing to do with the meteor. Well, we found materials that were never reported in solar system samples. And then they said, a few months ago, there were four of them who said it's coal ash. It's just something produced by humans, coal ash, on Earth. And okay, so we checked it. We looked at 55 elements from the periodic table and compared the Belau composition to coal ash and found it to be very different. And so it's not coal ash. And you just ask yourself, why would some people express opinions about materials that they don't have access to? One reason is simple, that they just don't like to see flowers rise above the grass level. Another is that, in academia, the strongest force is not electromagnetism, it's not gravity, it's not the strong force, it's not the weak force, it's jealousy. And when the expedition got so much attention from the public, it bothered people.
The Galileo project is such an exciting project, and some of the insights that you've shared from your recent paper, Recovery and Classification of Spherules from the Ocean Side of ʻOumuamua, has raised a lot of conjectures, like you mentioned. And there's a possibility that they could be from an alien probe or an alien spacecraft as well. And you make the case that in this case, the Sagan standard of extraordinary evidence justifies the extraordinary claim. So I highly encourage people to check out this project and the paper that you've published as well.